Alright, in this video we're going to be working BC Homework 1.4, and we've learned how to take the derivative of an inverse function, we've learned a couple more derivative formulas, and we need to put them into action. But before we do even, I think I'm just going to write down that one formula that's going to be really relevant to us, I gotta think throughout this video, and that's going to be the derivative of f inverse prime equals 1 over f prime of f inverse. Remember, f inverse itself is just an x value. Okay, so and that's not going to be relevant to us right now quite yet, but we go on. We see stuff about just inverse functions generally. Yes, this is where we're going to need that formula. Okay, first we're going to talk about our arctrig functions, and they have their own derivatives, and we do need to know those formulas for AP Calculus. So if we are tasked with finding dy dx, I'm going to use this opportunity to push these new rules plus a couple others that we've known about and just need to keep practicing. So if I'm taking the derivative of x cubed, I would have 3x squared. And the derivative of arctangent of x is going to be 1 over 1 plus x squared. Okay, arcsine of x squared, that's where we've got an outside and an inside, so we'll need to be observing the chain rule. So on the outside, I've got arcsine. And okay, we just recently learned that outside prime is going to be 1 over the square root of 1 minus that thing squared. Okay, it's a weird one. Okay, but if you actually go and look at why the formula is what it is, it makes a lot of sense. Okay, so 1 over 1 minus that thing squared. And then inside is x squared, meaning inside prime is 2x. Okay, now I'm going to get dy dx by multiplying outside prime times inside prime, but since, we've kind of moved on from the chain rule, I'm not going to be using the color all that much anymore. I was just kind of reminding you of what we did last time. Okay, so it's 1 over the square root of 1 minus, we're going to keep the same thing in the parentheses, and that's getting squared, and we're multiplying by 2x for the chain rule. We could maybe write this a different way if we needed to, say, recognize the right answer in multiple choice, but I don't think we do, so I'm going to just keep moving. All right, x squared arc cosine of x. Okay, x squared arc cosine of x, that's a product, so we're going to need to use the product rule. And okay, so, first I'm going to, I'll just use the color to talk about. First, I'm going to take the derivative of the easier looking one and leave the other one the same. And I'm going to add. I'm going to leave the red the same, and I'm going to take the derivative of blue. And we just learned that that's just like arcsine, but negative. So negative 1 over the square root of 1 minus x squared. And that's dy dx. Right, now this one, 2x over arctangent x, and unfortunately, no, this is not 2x tangent x, right? That would be if we had cotangent x in the denominator. This is the inverse function for tangent. This is the arc whose tangent is x. The angle, the most obvious place on the unit circle where tangent equals x. Okay, so I am going to be doing the quotient rule. And that's bottom times the derivative of the top minus the top times the derivative of the bottom, okay, and the derivative of arctangent is 1 over 1 plus x squared. Okay, and so we still need to divide by the bottom squared, so arctangent of x squared. Now that's a weird derivative, and I would not recommend you try to go and simplify that any farther. Okay, now x arcsine of 2x. Okay, so we've got a product here. We're going to need to use the product rule, but when taking the derivative of arcsine of 2x, I see there's going to be some chain. So set up for product rule. Let's say that y dx equals, first I'm going to take the derivative of red, and that'll be 1, while leaving blue the same. I'm going to add, leaving red the same, taking the derivative of blue. And the derivative of arc sine of a thing, I'm not going to use the O's and the I's on this one because I think we've got it. Okay, it's 1 over the square root of 1 minus that thing squared. And that thing was 2x. Then we need to multiply by the derivative of that thing for the chain rule. And there we go. That's going to be a suitable expression for us. Like, yes, we could definitely put the 2 and the x in the numerator of that fraction, right? We can say it's like that, and we could square the 2x and make it 4x squared, but I don't think we're going to need to do that. I think you'd be able to recognize the correct answer if it was, say, multiple choice, and, you know, that was the only simplifications you had to do. All right, y equals arc cosine of x cubed. Okay, on the outside on this one, I've got the third power. And on the inside, I've got arc cosine. So outside prime is 3 times that thing squared, and inside prime is negative 1 over the square root of 1 minus x squared. All right, so I'm just going to be multiplying outside prime and inside prime. And then times the derivative of the inside. Okay, so outside prime times inside prime. That's it for the arc trig derivative drill practice, and you know, hopefully it took you also less than 10 minutes, and that's always good to practice our derivatives and practice our new rules and formulas. So, what are the values of h of 5 and h prime of 5? And f is h inverse. Oh, okay, so I find it curious I wrote it like that, but I certainly can interpret that and remind you that that does mean that h is f inverse. Okay, so h of 5 is going to equal f inverse of 5. Okay, and when I'm confronted with something like f of 5, or f inverse of 5, I want you to just write down f of x equals 5 and solve for x. Okay, so f of x equals 5, that would be the output equaling 5. That's taking me back to x equals 4. So that means that f inverse of 5 equals 4. So h of 5 equals 4 there. All right, then h prime of 5, that's f inverse prime of 5. We've got a formula for this. Okay, we're going to say that's 1 over f prime of f inverse of 5. Now I'm just going to call it f inverse because I determined that was 4. 1 over f prime of 4. Okay, now I need to think about what is the slope of this line right here. Okay, at x equals 4 on the graph, you know, f prime of 4, that's the slope there. It's looking like I'm going up 3 when I go over 2, so that's going to be 3 halves. 1 over 3 halves. That's a safe place to stop. You could also call that 2/3. Yeah. No, all of these are similar problems. The table question, the graph question, the algebra question, it really all goes back to, you know, I use the formula 1 over f prime of f inverse, figure out what f inverse is, go from there. I feel like I had something else to say about it, but I can't think of what it would be, so I'm just going to jump into this next one and say, all right, g is f inverse, what is g prime of 2? All right, so that's going to be g prime of 2 is f inverse prime of 2, because g is f inverse. I've got a formula for this. f inverse prime is 1 over f prime of f inverse of 2. If you're just looking at it, kind of starting from the question, like I know a lot of y'all do, and then working backwards and saying, okay, well, what did they give me? No, I know they gave me enough to solve it, so figure that out after I get started on a problem. If you're doing that, then you're just going to kind of fill in everything as you see it, and then say, okay, now f inverse of 2. That's going to be where f of x equals 2. And f of x equals 2, that's looking like right here. Okay, so that's x equals 5. And remember, f inverse is just an x value. So I've got 1 over f prime of 5. And then I'm sure that's going to be in the table. Yep, f prime of 5 equals negative 3. I'll say, all right, that's equal to 1 over negative 3. G of x equals x to the 7 plus x to the 9. Let f be G inverse. Yeah, okay, yeah, I see how this is working. I'm afraid there was going to be... I hadn't thought this through, but no, I definitely graphed all these, made sure they were invertible. What's f prime of 2? F prime of 2 is G inverse prime of 2. Okay, so using the formula, we have 1 over G prime of G inverse of 2. Just like I did before, I'm going to grab G inverse of 2, take it off to the side. I'm kind of just thinking about it right now. G of x is going to equal 2. I've got an x value in mind. And that would be, okay, if you need to, you can write down x to the 7 plus x to the 9 equals 2. What's going to fit in there? It's not going to be 0. Let's try 1. Yeah, it works. Okay, and what I'm telling you, I told you in class, is that in AP Calculus, this value of x is going to be unique, and it is going to exist. So they're not going to send you on a wild goose chase where there's nothing to find, or they're not going to send you on a different type of hunt where you end up with, you know, 2 different things coming back. It's just going to be one thing, and if it's algebraic like this, it's probably going to be 0 or 1 or something you can really easily like envision the solution to, just with your eyes. Okay, so what's the value of f prime of 2? 1 over g prime of g inverse of 2, which is going to be 1 over g prime of 1. Okay, but I have not really taken g prime yet. I didn't talk about g inverse, but the derivative of g, I'm going to use the power rule. It's going to be 7x to the 6 plus 9x to the 8. Right, and then I can plug in 1 to get g prime of 1, and that would be 7 plus 9. All right, I've got 1 over that 16. You could even copy in the 7 plus 9 if that made you feel more comfortable, whatever it's going to take. All right, that's the value of f prime of 2. Ooh. Number 5, this one's interesting. Okay, like I told you in class, if you see this kind of expression, f of g of x equals g of f of x equals x for all x, go ahead and that's the definition of being inverse functions. You need to recognize that. So the takeaway is that f and g are each other's inverses. Okay, now f prime of 3, interesting. This one is going to give us just enough. I gotta think it's gonna be negative 5 over 6, right? Like, knowing how this stuff works, but I guess we could like try to convince ourselves of that. This makes me think of a multiple choice question that I do not use anymore, but that was really entertaining for a number of years. Led to a lot of good discussion, but it was tricky, and I think it was like this. So I'm not going to delay it any longer. F prime of 3 equals G inverse prime of 3. And I'm only thinking to do this because it mentioned the inverse function, and this is an inverse function homework, right? I would not normally think to do this, and okay, if I was going to do that, I would say 1 over G prime of, yeah, I see how this is going to work, G inverse of 3. Okay, remember G inverse is F. I'm just going to call that F of 3. Okay. And then they gave us F of 3, which was 4. So this is all to say 1 over G prime of 4, which is 1 over negative 6 fifths. And that's going to be negative 5 over 6. Okay. Now, if f is 2x plus cosine x and g is the inverse function for f, what is the value of g prime of 1? All right, well, so f inverse prime of 1, which is going to equal 1 over f prime of f inverse of 1. All right, and now I have to think about what f inverse of 1 is. Say f of x equals 1, and that's where 2x plus cosine x equals 1. Looking at that, that's going to happen when x equals 0. All right, so now I'm going to say I'm taking 1 over f prime of 0. And f prime of x, I can take that one off to the side. It's going to be 2 minus sine x. So f prime of 0, which is what I need to find, that's going to be 2 minus the sine of 0, and that'll be 2. Okay. That's a good one. X equals 3x plus 1 to the 5th power. Inverse prime of 1. Well, and we've got this. Let's say, all right, well, I need to find f inverse of 1. So I'm going to set f of x equals 1. Okay, that's only going to happen when I'm taking 1 to the 5th power. And that can only happen when x is 0. Okay, so again, x equals 0. And I think I might have told you in class, that's going to be a common theme for these algebraic ones. Okay, it's got to be something pretty easy to solve. And the things that we know how to solve typically are not that interesting to take the derivative of their inverse function. So that's where we land at this compromise. All right, so this is going to be 1 over f prime of 0. I'm going to take f prime of x. Okay, now this is a situation where I'm give a little bit of extra work. Off to the side, I've got my outside is the thing to the 5th, and the inside is 3x plus 1. And I'm going to multiply outside prime by inside prime. The inside was 3x plus 1. Okay. Then I am going to say, all right, I think really all I'm interested in is f prime of 0, so don't need to necessarily combine that and write it a different way. That's going to equal 15. And so, to answer their question, the answer is going to be 15. Right. Now we've got a fraction. Oh, I remember when I made this one, I was very proud of it. I hope this one works out. I don't think I thought... No, I did think about it. Again, that's why I restricted the domain. All right. G inverse prime of 2/3. It's going to be 1 over G prime of G inverse of 2/3. I was thinking there was too many that had x equals 0 be the inverse function value. I was like, I need something different, and I came up with this one. And it would also force us to use the quotient rule, and we have not done, I think we've only done that once so far in this practice set. So anyway, G inverse of 2/3. G of x equals 2/3. X over x plus 1. That's going to be x equaling 2. So I'm interested in 1 over g prime of 2. And I'm going to need to take g prime of x using the quotient rule. So it's going to be bottom times the derivative of the top. Okay, multiply by 1 minus the top times the derivative of the bottom, which is also going to be 1 divided by the bottom squared. And, if you want, you can simplify it, but, it's going to work out the same way either way. And I think I'd trust myself with this arithmetic. G prime of 2 is going to be 3 minus 2 over 3 squared. So that would be 1 over 9. Yeah, I do remember thinking about this one. 1 over a ninth is going to equal 9. So I liked that problem for all sorts of reasons. Okay, back to the tables. Now, I think, we're going to maybe get some more diverse questions. Yeah, kind of just some like free response prep. And I think that, at this point, that's exactly what you need. We've done plenty of practicing of the slope of the inverse function. Looks like we're going to do a little bit more. That's good too, but we also need to be practicing our other rules kind of a whole lot more than this one, because this one is not the most important for AP Calculus, or really for any study of calculus. All right, number 9, slope of the tangent line. That's the derivative of G inverse. G inverse prime of -1. Compute that using the formula 1 over G prime of G inverse of -1. I'm going to be thinking about, where does G of x equal -1? It's right here, and they're always going to do that to you, where they have that also be an x value, because they, this is going to be a multiple choice question if it shows up on the AP exam, or honestly on my exam. And we want to have good wrong answer choices. So yeah, it's going to be, you're going to see -1 elsewhere, okay, but neither of those are what we want. We want G of x equaling -1. So we go and we look over there, it's going to be x equals 2. And so that's going to be 1 over G prime of 2. And, okay, so that's going to be G prime of 2 is -3. So I say that's 1 over -3. Okay. We're good without the annotations on the table. We're going to say, all right, f of x equals 1 over G of x. What is f prime of 0? It seems kind of familiar. So 1 over G of x. You can do this with the quotient rule if you like. I'm going to use the power rule and the chain rule, but totally up to you. We will get the same thing. It'll even it'll look the same too. So I'm going to rewrite f of x as G of x to the -1 power. So on the outside, I've got the thing to the negative first. Its derivative is negative of that thing to the -2. Inside is G of x, and inside prime equals G prime of x. All right, so f prime of x is going to equal the negative of g of x to the negative 2 multiplied by g prime of x for the chain rule, and then I'm ready to plug in for 0, and f prime of 0 is negative of, all right, g of 0. G of 0 is 4. That to the negative 2 power times g prime of 0 is negative 7. Now remember that the exponents are going to come before the multiplication by negative 1 on that negative of 4 to the negative 2. Okay, so it's going to be 16 in the denominator, the two negatives make it positive, so 7 over 16. Right, oh, there's another one up here. Now we got some product here, so we're going to use the product rule. Say h prime of x equals 2x g of x plus leave x squared the same, take the derivative of g. At x equals 1, plug in x equals 1, 2 times 1 times g of 1. G of 1 is 2 plus, it was asking for negative 1, not 1. Okay, so it's going to change this. 2 times negative 1 times g of negative 1 was 6 plus x squared. G prime of negative 1 is negative 1. So negative 12 minus another 1 is negative 13. All right. We got another table question. Looks like, okay, yeah. Okay, about what we would expect. Okay, this one's looking kind of interesting. This one's going to have product and chain. Okay, so I will, all right. Taking the derivative of red is going to be really easy. Taking the derivative of blue will involve chain. It won't be that bad, okay? But and maybe I'll go off to the side and do some work on that. But first, I'm going to say a prime of x. First, I'm going to take the derivative of the easy one. Taking the derivative of red would be 1, and I will leave blue the same. And add, leaving red the same, taking the derivative of blue. So on the outside, I've got f on the inside, it's 2x minus 1. Inside prime would be 2, and I go over here and I say, all right, x, and I'm multiplying by the derivative of blue, so that's outside prime times inside prime, so f prime of 2x minus 1 times 2 for the chain rule. If you're annoyed with me for doing the O's and the I's on that one, then good. I am honestly so glad. But if you are, liking this and want to keep doing it with me, then keep doing it. If I'm being honest, I'll probably do it for about another week or maybe half a week or so. I'm not sure how long I'm going to hold on to the O's and the I's, but at least as, throughout this unit. Once we move on to the next unit, probably that's when I'll leave it behind. Okay, and then we want a prime of 2, so that's going to be f of 4 minus 1 plus x is 2, f prime of 4 minus 1, and then multiply by 2 again. Okay, so I need to look these up. F of 3 is 10, plus 2 times 2 is 4, times f prime of 3 was negative 4. So I've got 4 times, so 10 minus 16, that's going to be negative 6. Right, writing an equation for the line tangent to the graph of g inverse of x at x equals 2. I had to make sure I did at least one of these in the problem set, but I was not going to put it at the front because I don't like I don't love this problem because I don't love graphing an inverse function and the original function on the same set of axes. It just doesn't really make a whole lot of sense to me. But, you know, I have seen this question before, so I should prep y'all for it. So we're going to need a point, a slope. So the point, I'm just going to try to approach this the same as always. X equals 2, and y is going to be g inverse of 2. Now to find that, I'm going to say g of x equals 2. That's going to give me some x value, and I have faith. All right, g of x equals 2 right there. That's x equals 1. Okay, it's going to be like that. And then I'm going to say the slope. I'm going to use the derivative. G inverse prime of 2 is going to be 1 over g prime of g inverse, which was x equals 1. 1 over g prime of 1. G prime of 1 is 5. Fifth, and then I will write the equation. Using point slope form. All right. Yo, just 2 more problems. Okay, so here I've got a quotient rule and what is looking like a chain rule. Yep, f of g of 2x. If you hear yourself saying that of too many times, you know this one's got a middle layer of chain. And couldn't let this whole practice set go by without one of those as well. I'm liking this homework. I've had many iterations of BC Homework 2.4. I mean, they were just getting less bad over time, but I feel like this one finally is one I would consider to be good. So on the outside, we've got f. In the middle, I've got g. On the inside, I've got 2x. Okay, another thing that's nice about this as a scaffold is that it's you can kind of be flexible with it, and you could say that the inside was g of 2x if you knew that the derivative of g of 2x was going to be 2g prime of 2x. You're good on those constants. That would be a good way to kind of start to do some of these mentally. Okay, outside is f prime, middle prime is g prime, and inside prime is 2. So b prime of x will equal f prime of something multiplied by g prime of something else multiplied by 2. And what's going to go inside of f prime is what originally went on the inside of f, which was g of 2x. What goes on the inside of g prime is what originally went on the inside of g, which was 2x. And then I've got a formula I can plug in on it, b prime of 2. F prime of g of 4. Probably just going to use an eraser for that one. Times g prime of 2 2's multiplied by 2 for the chain. Okay, now I'm going to need g of 4. G of 4 is 6. How am I supposed to get f prime of 6? Oh, goodness. Oh, no. Oh, no, I must have meant 1. All right, so, yeah. I don't think I actually meant 1. I just don't know if I thought this one all the way through or what I was thinking. But if I change it to x equals 1, and hopefully that's what you're seeing on your paper maybe next year, in the future, once this is an old video, f prime of g of 2. G of 2 is 3, so I want f prime of 3 times g prime of 2 times 2. So f prime of 3, negative 4. G prime of 2. G prime of 2 is 1 times 2, and we can do that. That's negative 8. All right, now the last one. Q of x equals g of x divided by f of x. What is q prime of 1? All right. Q prime is going to be bottom times the derivative of the top minus the top times the derivative of the bottom divided by the bottom squared. Okay, then q prime of 1. That's a lot of looking up from the table. Okay, so see, f of 1, 6, and that also goes down here. Okay, g prime of 1, so that's 5, minus g was 2 times f prime was 4. 30 minus 8 is 22 over 36, 11 over 18. Is that any better? I don't necessarily think so. All right, so that was a solid set of practice problems for us, right at our level, right what we just learned, but not too much of that. Remember, if you're, prepping for the test in my class, that derivatives of inverse functions are really not that big of a deal, and we're looking at like one question. What you really need to be doing is practicing that product rule, quotient rule, and chain rule. But if you look back at this homework set, you will realize that that's exactly what we've been doing here. So thanks for being with me for this one, and that's all.